Okay, guys, section 9.2, simplifying square roots. Now, you're going to remember because we talked about this yesterday, but we can multiply radicals. Do you remember me putting this one up on the board? I said that the square root, whoa, I'm sorry. I said that the square root of 4 times the square root of 9 equaled the square root of 36. Do you remember us doing that yesterday? Do you agree with that? 4 times 9 does give me 36. But then also the square root of 4 is 2, right? And the square root of 9 is 3. Good. And 2 times 3 equals 6, right? And each of these numbers are the square roots, or the simplified forms of those radicals. Does that make sense? Now, I want you to watch something. When I look at this example number 1, it says simplify the radical expression. And they want the square root of 180, and I don't know that off the top of my head, right? I'm thinking it's somewhere between 13 and 14. You guys know that? 13.4 about? Okay. But you know what? We're not going to do that here. We're not finding its decimal approximation. Okay? What we're going to do is we want to take out any perfect squares that they have in them already. Okay? I want you to watch this. Do you agree that this is the square root of 9 times the square root of 20? You agree with that? Right? Times, right? Look, do you see how this is a factor tree? Right? 9 times 20 equals 180. So the square root of 9 times the square root of 20 equals 180, right? I'm sorry, square root of 180. Now let me ask you something. Hang on, okay? Why didn't I pull out 9? Why not just 2 times 90? Why didn't I pull out the square root of 9? Why would that be one that I'd want to pull out? What do you think? We'll see. 20 and 9 are closer. 18 and 10 are probably even closer. Yeah, they're both divisible, but one of those things is kind of special. What do you think, Kintara? Oh, the square root of 9 comes out evenly to a whole number. I like it. I like it. Do you see that this is 3? Right? What about 20? Can I break 20 down? Is there anything special that goes into 20? What do you think, Quaza? 10 and 2 I don't really like because none of them are perfect squares, right? 5 and 4. Now I do like that, Quaza. Root 4, root 5, because that equals root 20, right? Does that make sense, Milan, where I am? Okay. Do you agree that this is 3? I'm just going to bring this straight down, right? There's my little arrow saying I'm bringing it down. What's 4? How can I rewrite that? How can I rewrite that, Spencer? As well, the square root of 4 is 2, isn't it? Right? So it's 3 times 2 times the square root of 5. Is there a perfect square that goes into 5? No, in fact, 5's prime, isn't it? So how would I write my simplified answer of this? How would I do that? What is that? What do you think, Willar? Can I just squish it back together? I want to put it back together now. 3 times 2 is 6 root 5. You know when a number is written right next to it, it means multiply, right? Okay, so 6 root 5 is the simplified form of the square root of 180. Now I want you to do something just before I leave here and before this gets into the red. Do something for me. Brahm, will you find out what is the square root, the decimal approximation of the square root of 180? Will you find that for me? And then I want you to do this, Milan. No, I want you to finish writing that. Julian, will you find out what the square root of 5 is? Do that first, and then multiply it by 6 for me. Don't say anything. Hang on. Okay. Root 180. What do I get for root 180, Alex? Wait. 41640? Yeah. 787? And there we're good? Okay, good. Because the screen has to stop at some point, right? It never does stop, does it? This goes on forever. This is irrational. Okay. What'd you get? 6 times the square root of 5 is equal to what? Did you get the square root of 5? Now times 6. The exact same thing, isn't it? 6 times the square root of 5 is the same as the square root of 180.